Hi, everyone. We're very excited to be part of the conference. It's been a while since it actually was supposed to happen, but we're very excited that it still is happening, especially in these troubling times. So big shout out to the organizers for making everything happen. What we're going to talk about today is we know that RxJS has a very steep learning curve. And if we look at how we learned, for instance, how I specifically learned about RxJS, I looked at Stack Overflow, I looked at a lot of questions, tried to answer a lot of them. So I tried to do a lot of things. I made a lot of examples, and that's basically how I learned it. So that's what we want to do today. We basically went through our own base. We looked at a couple of examples we thought could be interesting. We basically extracted them. And we want to show you these slides, these examples. Without any slides, it's going to be almost purely live coding. So we hope you can draw a little bit of inspiration from this for your own projects. So a little bit about ourselves. My name is Kwinten.
And I'm Dominic. Hi.
Yes. Hi. We both work for Stackblitz. So at Stackblitz, we're currently building the next generation in browser editors, and we're also both Google developer experts. A small plug about Stackblitz. We actually just released Stackblitz for Enterprise, which is basically the same thing as going to stackblitz.com, but on your own on-prem installation or in a VPC, where you can connect your own NPM registry, where you can use your own SSO, you can use security, audit logging, and using Stackblitz not only online, but also within your company, or bug fixes, reproduction, small proof of concepts, prototyping, whatever you want. So if you're interested, definitely shoot an email to enterprise@stackblitz.com. And then it's already the last slide. So let's go to the examples. And the first example I want to show you all is something we like to call progressive data enhancement. So what is it? When you're building UIs, it happens quite often that you need to fetch some data, and based on that data, you need to fetch something else from a different service. Think about the example where you're, for instance, building a web shop. You need to fetch the list of products, and then you also need to fetch the rating for every product, but that's from a different API, so you need to fetch it separately. And this is something cool we could do. So let's try and implement this a little bit together. So I have a very small example where you can search for Pokemon, because Pokemon are awesome, obviously. So I can fill in the name, and I can click the search button, and then I get the image, I get the name, I get the type, but then I also want to show what the next evolution of this Pokemon is. And this is something I need to fetch from a different service. So let's try and do that together. So what do I already have? A little bit of gluing code, which doesn't matter, but I have this from event here, where I'm basically listening for all of the clicks that are happening on this search button, which is pretty cool. Whenever I have that observable and every time it emits an event, I'm going to map it to the input value. So I'm basically extracting the name of the Pokemon that I'm searching for. And then I'm using switch map, because switch map allows me to map the name of the Pokemon and then fetch the actual Pokemon using this utility function, which just does an AJAX request and it logs out fetching the Pokemon. Let's open this so you can also see that. What do I want to do now is basically whenever I fetch the Pokemon, I also want to fetch its evolutions. So to do that, I am going to take this inner stream here, and I'm going to pipe over it, and I'm going to do another switch map, and I'm going to take the entire Pokemon, and I'm going to use this other utility function that I have to fetch the evolutions. And to do that, I need to pass in the ID. So now whenever I fetch the Pokemon, I'm going to enter my second switch map, and using that switch map, I'm going to fetch the evolutions. And the next thing I need to do is I need to enrich my existing Pokemon with the evolutions. To do that, I'm going to use the map operator. So I'm going to get my evolutions here, and I also have this utility function to do this. So I could say add evolutions to Pokemon, where I pass in the Pokemon and I pass in the evolutions. I actually still have access to the Pokemon here because I'm still inside of this switch map closure. So right now, if I go to the screen and I search for Bulbasaur, for instance, and I click search, do not only see all of the standard information, but I also see which Pokemon it evolves to. So I basically enriched my data from this between the first and the second call. But doing it this way actually imposes a couple of problems. So one of the problems we have is, let's imagine that the second call actually takes 5 seconds to complete. So if I search for Bulbasaur now and I click on search, you'll see that even though I've already fetched the Pokemon information, I don't see anything on the screen yet, which doesn't necessarily make sense. I'm showing 4 properties of this Pokemon, the image, name, type, and what it evolves to. I already have 3 almost instantly, but I'm not showing it. So let's try and fix that so we already show the information that we do have instead of waiting until we have all of the information. So how can we do that? I'm first going to make this a little bit more return. Let's format this a little bit. Okay. Let's put this on a new line. Okay, so what do I want? I want to get an end stream, which basically emits the Pokemon immediately, and then it's going to emit the evolution enriched Pokemon a little bit later. If I look at this piece of code here, this return statement, let's do it this way. Formatting is hard. Going to emit with the evolutions. I already have that stream. So I could say evolutions, I already have this stream. What is another stream that I need? I also need a stream that's going to emit the Pokemon immediately, because that's what I need to get my end result. So what can I do here? I could say const Pokemon equals, and then I can use this static method from RxJS to create an observable. So I could use off. So now I have a stream that emits the Pokemon immediately, and I have a stream that emits the enriched Pokemon with the evolutions as well. What do I need to do? I need to combine these two observables so that I get the observable that I'm looking for. And to do that, in our use case, I'm going to use the merge operator. So I'm going to say return merge, and I'm going to merge the Pokemon stream with the evolution stream. So now, if I look here and I would search for Bulbasaur, what I'm expecting to see is I'm already almost immediately going to see the data for Pikachu, and then we're going to see the data for the evolution come in a little bit later. So I'm going to search here, see this is still loading, and as soon as it arrives, we can see that it's enriched. So this is a really nice user experience because we basically show whatever we have and we augment it a little bit later. So that's kind of cool. This example does have a couple of issues, however. First of all, let's say that this first call also takes a little bit of time to complete. Let's say it also takes 5 seconds. Let's say that I search for Bulbasaur, and I'm a very impatient user, so I click, I don't see anything, I click again, I click again, I click again, I click again. That's a problem, because the call should have taken 5 seconds, but now it takes 5 seconds after my last click. And the reason for that is that in this switch map, what switch map does, it is only going to listen to the last inner observable. What does that mean? As soon as this stream emits, which happens every time I click, switch map is going to stop listening to this observable, and it's going to start a new observable for the new name. And that's not really what we want, right? If we didn't change anything to the input field, we want to protect our impatient users from having a really bad user experience. So what we could do is we could actually use a different operator, which isn't super known, which is called exhaust map. And exhaust map handles the inner subscriptions very differently. So now if I search and if I click again, you can see that it doesn't necessarily start a new call. It's fetching the data, and it's going to keep fetching the data until this inner observable is completed, until it's finished. And that's cool because now I'm protecting my user against his own impatience, basically. So that's super cool. It does, however, introduce a new issue. And this new issue is, so let's restart this blitz. If I search for Pikachu, for instance, and I search, and then I change my mind and I say, oh, let's search for Bulbasaur anyway, I'm going to click. But remember, since this observable was still looking for Pikachu and hadn't completed yet, ExhaustMap basically ignored the new Bulbasaur string coming in. So I'm looking at Bulbasaur in my input field, but I'm looking at Pikachu as my result. So that's not what we want. So what we want to do is we want to make sure that this doesn't happen. And the way we could do that is we could basically say to ExhaustMap, like, stop listening to this observable. And the only way we could do that is by making sure that it's completed. And to do that, we could say, I want to take values from this stream, but I only want to do that until I actually start typing into my input box again. Because as soon as I start typing in that input box, it means that I'm not interested in those old results anymore. I want the ExhaustMap to start a new inner observable. And to know when I'm starting to type, I could say from event, I could listen to my search input, and I can listen to the input events. So now, if I search for Pikachu, I click the search button, a call is started. I immediately switch to Bulbasaur, search again. You can already see that it started a new call. So I protected my user against his impatience, but I also made sure that he doesn't look at stale data. So only using a couple of lines of RxJS code, I was able to progressively enrich my data. The user can immediately see what he can see, and we enrich it later. We made sure that he cannot be, doesn't have a bad user experience because of his own impatience, and we also made sure that he doesn't have to look at stale data, which I think is kind of cool. Second example I want to show you is an example regarding error handling. It's something that I see that often mistakes are made against. So let's see what we can do here. We have a small piece of code where we have an interval which emits every second. Then we fetch some data, we map it to the response, to the name, we take the first 10 events, and then we log out the next and the error events. What's specific about fetching this is that after 5 times, we're deliberately going to make this call fail. So if we look at the result here, we'll see that we get Pikachu logged out 5 times, which is what we expect. Then we get an error. But in this case, I actually still want to keep fetching Pikachu. It doesn't mean that one of the calls failed, that I don't want to continue. And this is kind of obvious, right? I totally forgot to catch error. I need to catch an error if it happens. So I'm going to catch this error. And when an error happens, I basically don't want to do anything. So I'm just going to say never. So let's try this again. We see Pikachu being logged out 5 times. Now we don't see anything. And now we should, oh no, nothing's happening. Why is nothing happening? Well, this is basically because of the observable contract. An observable will always can emit 0 to n next events, but it can only emit 1 error or 1 complete event. Because of the fact that this observable failed at the 6th try, it actually emitted an error event. And once an error event has been emitted, the observable chain has been broken. So it's going to unsubscribe upwards and it's going to send the error downwards. So because it unsubscribes, this one doesn't emit again because it had an error. So that doesn't work. So what we need to do is we need to make sure that errors, if we want the stream to keep on living, we need to make sure that errors never happen on the main observable chain. So what we need to do is we actually need to move this error handling inside of the switch map so that the main observable chain be the error. So now if we run this again, we should be able to see that we log it out 5 times. Then we have the error, so we won't see anything for 2 seconds, but then we keep seeing everything logged out, which is kind of cool. Last thing I want to show real quick is another trick that I like to use, especially when you're building apps which are not necessarily always connected to the internet. One trick you could use is you could say retry when a call fails. And then normally in here, you would check if it failed because the user lost his internet connection. For the sake of this exercise or this example, I'm not going to do that. But you could say, I want to retry this whenever my user gets back online. And to do that, we could say whenever, so I'm going to say from event again, my window emits the online events. So whenever you emit the online event again, I want you to retry this. Obviously, I cannot test this because I cannot kill my internet connection because I'm not live at the conference. So just to mimic this, like a really small example, which would be the same, is I have this online stream which kind of mimics this with a button. So I could say, let's wait till it's over and restart this. So I'm online, I go offline. You can see that it's not being logged out anymore. But as soon as I go back online, you can see that the call actually restarts. So that was the last example I wanted to show you. So Dominic, over to you.
Okay, thanks. Yeah, so I basically just want to continue with user experience because I think user experience is great and it makes you think. So I have two more examples prepared for you, and I'm just going to share my screen now. And then we can jump over to, hopefully you can, oopsie. All right. So another quirky behavior on many websites and many applications is flickering spinners, right? So a spinner, if you fetch some data, a spinner that pops up briefly and then disappears almost right away. And so I have this example to simulate this. So here we have three parameters that we can play around with. For instance, we can specify how long the actual fetch call takes to complete. Then I can say, like, after how much milliseconds we want to show a spinner, and then for how long we want to show a spinner, like at least for, let's say, 300 milliseconds. But the problem, here's the problem, like if the call only takes 50 milliseconds and we show the spinner right away, and if I click now on the start button, we can see that the spinner comes up, but then disappears like immediately. And I think this is a bad user experience, and I think we can do better, right? Because like flashing animations basically lead to a cognitive load, which, or in other words, basically animations become destructive. And these days, we know that bad user experience is really a killer. So let's try to solve this in a more improved way. And for this, we can start from scratch, and I've already prepared a little bit of code so that we don't have to really start all the way from scratch. And I have this very useful to-do here that reminds me of what we have to do. So we have to implement the spinner, right? So essentially, I'm using from event. I'm listening for click events on this button. I'm also using exhaust Mac because I do not want to restart this thing over and over again. When we click on the button, I first want to like wait for the inner observable to complete and then start another one. And then essentially we're fetching some data. So the heart of this example is the fetch data function, which does everything. Right now, there's no spinner. This is something that we have to implement. And so our first observable is just a simulation of an AJAX call. So we're just using like off and emit a value, and we only emit this value after a certain delay, which is specified by this first parameter that comes from the UI. Now, the spinner itself, right? So there's a couple of like building blocks to the spinner. I think the first thing that we have to do is we need to show a spinner. And so I'm going to create a new observable here. Oh, okay. So this is going to be show spinner here, show spinner. And when do we want to show the spinner? Well, I think we want to show the spinner after a certain delay as well. So, and 1 second, I think I have to change this to, because it's like reloading, let's say, never mind. So we want to show this after a certain delay. So we can say off true, and then we can pipe delay the emission by the parameter that is specified by this variable, show spinner after. And then we also have to make sure that we actually toggle the spinner in the UI. We don't have to take a look at this. This is a utility function that I've already prepared. So we can say toggle spinner, and we could pass in the value that is emitted, which in this case is just true. So this is our stream that is responsible for showing the spinner in the UI. And now we actually need our spinner because that doesn't really do anything just yet. So our spinner, for our spinner, we will basically run a couple of observables in sequence. So it's like a step-by-step process that we have to build. And so the first step of this is that, as I said, we want to run these in sequence. So we can use concat for this. And so the first step is to show the spinner, right? So I'm gonna do this first. And if you think about this, right? So we're using concat. So we can picture this as an observable that runs a couple of observables in sequence. So first of all, we're going to show a spinner after 300 milliseconds. So let's say every dash is 300 milliseconds. So then we're going to show this spinner. It's going to complete. And then the next thing in that pipeline has to be our data call, right? So we want to start another call, which then triggers the data to be fetched. And then that's basically like, and then when this call is completed, we want to hide essentially our spinner again. And so what we can do is we have our data observable here. So I'm just gonna put it in as our last step. And when our data observable emits, we just tap into and just toggle our spinner and hide it. Oops, excuse me. And hide our spinner. So this is our spinner. Now we have the spinner, and now we have to make sure that we show the spinner. And what can we do here? So essentially what we want to do is we want to raise the pure data stream against our spinner. Because the idea is that if the call is like really fast, if the fetch call to some backends is really fast, we don't want to show a spinner. We just want to like fetch it. If it only takes 100 milliseconds or something, then we won't show a spinner. We only show a spinner after a certain period of time. And so we essentially want to start this race of the spinner and the fetch call. And there's a very useful operator which does that already, which is raise. And so we can raise data against our spinner. And so what raise does is so the first observable to emit a value that we specify here is mirrored by the raise operator. So the first one that emits a value wins the race, and then that particular observable is mirrored. And so this should already show a spinner in our UI here. So we say show the spinner after 500 milliseconds, and the call takes 2 seconds. So 500 milliseconds, we've seen the spinner pop up, and then it disappears. Great. But why does it take 2.5 seconds? I mean, we show the spinner after 500 milliseconds, and the call takes 2 seconds. Then ideally, the whole call should only take 2 seconds, right? And so the problem in this case is that we don't share a subscription to the underlying data source, right? Because raise will subscribe to data. However, if the spinner is triggered first, this one wins the race. So we show the spinner, and only then we subscribe to the data observable. So we're not sharing one underlying subscription. And this is quite easy to fix because we can essentially just plug in share replay and specify the buffer to be 1, and then we should be good to go. Now, if I click on start, we can see that the spinner comes up at around 500 milliseconds, and then the whole thing only takes 2 seconds because now we're reusing one subscription to the underlying data source. Okay, but what if, what if the call takes, let's say, 1.1 second. We show the spinner after 1 second, right? Now, if I click on start, what do we expect? Well, it only takes 1.1 second, but still, we haven't really solved the problem of like the spinner flickering, right? We haven't really solved the fundamental issue here. So because we have not accounted for this last parameter, which is a minimum amount of like time that we want to show the spinner to avoid flickering. And for that, we can just implement another stream, which will delay the spinner for a while. So I will call it delay spinner. And for this one, we're going to use timer. And so we're going to so here we have another parameter, show spinner for, right? So we're going to use that here. So we're going to show the spinner for at least 300 milliseconds as specified in the UI. And because timer emits like continuous values, and this is not what we want, we will just take the first value here, right? So if we now plug this in our sequence here for our spinner, this basically means only show the spinner after 500 milliseconds. Then the next thing would be like this will emit a value again after 300 milliseconds. And then it will subscribe to or connect to the underlying data source. But in that case, it will probably be already finished. And that's, we will see the spinner for 300 milliseconds and then we're done. So if I now say, okay, the call takes 1.1 second, we show the spinner after 1 second, and we show it for at least 300 milliseconds. If I click on start, it takes now 1.3 seconds because as specified here, there's a minimum duration for the spinner to avoid flickering. And you can really play around with these numbers to, well, create the user experience you want. But this is just one way to solve the problem of like flickering spinners. And I hope that gives you some insights on how this could be solved. Another example that we have prepared here is this one. Now, let's take a look at this. What we have here is a very simple AJAX call to, again, fetch some information about Pikachu, because we love Pokemon. And so we trigger this AJAX call to the server to get some information, and then we map the response to just the name, right? And if I open up the console and reload this, and we can see here on the left that we subscribe 3 times and then another time after 1 second, we can see there's like information, the same information 4 times. Now, why is that? That's because an HTTP call is essentially under the hood a cold observable. And a cold observable means that, well, there's a one-to-one connection between the underlying source and the subscriber. So every subscriber will re-trigger the producer or the underlying source. And this is not always what we want. And in some cases, it's also very difficult to debug, right? And so we could build our own operator, which I've done down here, and I've called it subscribed to. So we can take this operator and plug it in any observable pipeline to figure out how many total, like what's the total number of subscribers and how many active subscribers do we have. So an operator is essentially just a function that could take in some options, some configurations, and it has to return, well, if you have options, then it's essentially a function that returns a function. If we don't have any options, then we could also just emit the outer function, and just the operator itself is just a function that takes in a source, right, that we want to subscribe to, and then just like intercepting values that are coming from that source, and then we can do whatever we want. In this case, essentially, we have this operator function, we receive the source, we always have to return a new observable. That's how operators work. And I think Niklas in the next talk will probably give some more insights on operators, so definitely check that one out. But in this case, what we do is we track the total number of like subscribers, we track the active count of subscribers. And so we're essentially just subscribing here to the source, listening for the complete event, so that we can reset everything. And then obviously we have to like forward that to another operator that might be coming after this one in the chain. And this is what the observer.complete does. It's just forwarding it again, like downwards. And then we also have to make sure that we provide this teardown function so that when we unsubscribe, we unsubscribe from the source because we're building up the subscription to the underlying source. We also have to make sure that we unsubscribe from this. But essentially, it's just tracking the total number of subscribers. And now if I take this operator, and plug it right into my Ajax observable pipeline here, and say get Pokemon $, then we can see here in the console that Pokemon has been subscribed 1 time, 2 times, 3 times. There's 3 active subscriptions. At some point, it has completed. So it's unsubscribing from it, 0 active subscribers, and so on and so forth. So this is already an indication that we're triggering the Ajax call multiple times. So the underlying source is triggered multiple times. And well, one way to solve this is to just plug in a share replay, for instance, so that we make this observable warm, and it's a ref count under the hood. And now what we see, even though we have 4 subscribers, we can see that it has been subscribed to once. And this is what share replay does. It's kind of like, proxying all incoming subscriptions and only establishing one single subscription to the underlying source. And then just, kind of like proxying it and relaying it, multiplexing it. So there's only 1 subscription and only 1 active subscription. And then at some point it has completed, and then there's 0 active subscribers left, and that's basically that's it. And so I think this gives some insights on.
Excuse me, Dominic. Yeah, we kind of run out of time.
Oh, sure. But I'm
if you want to go through quickly for the last example, or just yeah.
No, it's fine. I think I'm done. So thank you very much for listening to us.
Excellent.
This is our Twitter handle. So if you have any questions, give us. You can always hit us up on Twitter. So yeah, thank you very much.
Yeah, awesome, great. Thank you very much.